Hello everyone. This is the presentation of the data mining mini project Data Chautari or data visualization dashboard on GitHub users. So we will be carrying out this session into two phases, data preprocessing phase and data visualization. On data dashboard, which will be given by my teammate Monish Shinwar. So I will be walking through the data preprocessing phase of our project. So for the visualization in the dashboard, we needed the well-structured and clean dataset. So firstly, we gathered the dataset by using the GitHub's API request and with queries for fetching the user's data globally with fetchers and users repositories and we with the queries for randomly shuffling over the 4 time periods and here we handle the rate limits with the help of the paginations. We fetch the aggregated queries and export it into the CSV format, and we fetches around 11,000 data samples, and these data sets captured 19 features, namely country, repositories, count, followers, most used language, total stars, and so on. And the fetched datasets can be seen here as messy and raw, and their preprocessing phase uh, begins with uh, removing columns and handling missing values and filling and cleaning and so on. So preprocessing here the preprocessing files are self-explanatory, and here, in the removing column, we selected only the few meaningful columns for the data visualization and dropped the few irrelevant columns with the personal information like username, profile URLs, public email, bio, and so on. And the remaining 9 key features were saved. Similarly, for handling the missing values, we took a look on our datasets and find these missing values, and we filled the missing values in the hireable column with a false. The hireable column is a boolean feature which takes true or false value. As the API GitHub API request fetches the data for hireable column with with false as null, so the null values in the hireable columns are filled with false, and the level gaps in the country column as unknown. Similarly, so the country column can be seen with a random and unstructured location in it. So we used a standard geographic structured location dataset and mapped accordingly for standardizing our country column in our dataset. We again found a few missing datasets in the number of hundreds, so which were simply dropped as it has less impact in our overall dataset. So finally, the data types of the each columns were handled, and the final clean and meaningful datasets for revealing insights was ready for data visualization. Now for the visualization part, Monish will be presenting the data visualization dashboard.
Thank you, Sachin. Hi everyone, I'm Manish and I'll be presenting you the visualization part of our mini project Data Chautari. On the screen, you can see a GitHub users dashboard. This dashboard comprises of many elements, and I'll be walking through each of these elements uh, and explaining you. And finally, I'll show you a demo of how each components actually interact with each others. So let's start and get started with choropleth map. Choropleth map shows the distribution of GitHub users by countries. You can see the map has been color graded with various shades of blue. On the scale, you can also see white means 0 and the darkest blue means 2621. Similarly, there are few parts of the a map where it's actually gray, and the gray means there are missing users. The second one is a line chart. The line chart shows the trend of GitHub users over the years. The year expands from 2007 to 2024. Similarly, the third one is bar chart. The bar chart shows the distribution of GitHub users by countries. As you can see, the cyan means hireables and the red means non-hireables. The hireables are 1793 while the non-hireables are 6524. The next is the donor chart. The donor chart shows the distribution of GitHub users by programming languages. As you can see, there's JavaScript, there's Python, there's Java, there's Ruby, and JavaScript comprises of the major part, that is 24.3%. The next one is Python, that is 15.3%, and similarly the third is Ruby, and similarly there's Java with 7.6%. And if you can zoom in here, it shows the others as well. What does the others means? There were many languages, and incorporating them in a single donor chart would be very cumbersome. So we decided that the languages with very few numbers said should have different segment to it, and so the other has the other languages. Like if you can click on it, you'll actually see various languages there, like Scala, Luga, Clojure, and Emacs Lisp. Okay, no. Now the third one, the next one is histogram chart. Histogram chart shows the distribution of GitHub users by the activity. As you can see, on the x scale there's followers count, on the y there's the repo count range, and the histogram chart actually shows the GitHub users activity that is for a particular languages. Like for JavaScript, you can see there, and on the Python you can see it changes. And the next thing you can notice here is a blue box here, and it is the filter. Once I click on the languages, it will show the blue filter, and if I cross it, the filter removes. Similarly, the next one is chart that shows the top 5 most used programming languages, and you can see there's the JavaScript with 2022, similarly Python with 1270, Ruby with 896, Java with 633, and finally Go with 322. The next to the bar chart, there is a line chart that shows the trend of GitHub users over the years, and by the scale you can see JavaScript adoption rate here. It shows how a JavaScript has been evolving over the years. So it basically shows how a programming language has been evolving or devolving over the years. And finally there's a word cloud. And what does the word cloud show? The word cloud shows the most common words in GitHub user bios. So to be a little bit playful, we have decided to create the word cloud to be a 3D object, and you can zoom it, you can play with it. So like I said, these are the components of our dashboard. Like I have skimmed through very surfacely. Now let us take an example on how they are actually interactable. Before showing all those interactable components, I think you can see a play card here, and it shows the Git users count, and similarly a progression arc. The progression arc actually shows how many percentage of the users have been selected. So for now you can see there's 8,317 users, and the next down to it there's a world. So let us take an example of United States. Once I click on the United States, you can see there's a filter called United States up on the dashboard. You can see the GitHub users has now changed to 1679, and the country has been changed to United States. Similarly, the progression arc has been 20%. That means the GitHub users are 20% of the total populations, or for this data set. So similarly, the line chart, I'll be explaining that a little bit later. And there's a change in the bar chart. Bar chart shows that now the hireables are 336 and non-hireables are 1343. Similarly, the donor chart has also changed. You can see JavaScript is still the most used language, with major portion, that is 423. Similarly, second one is the Python, and second one is the Ruby with 262, and there's a Python with 257, and finally there's the other segment that I have explained earlier. Once you click on the others, you can see there are many languages still. Moving on, we can see there's the follower count and the repo count. It shows how a repository count actually changes the followers count. So you can see if a repo has 28 to 30 scale, then the followers count is vastly changed, like 4645. And similarly, as the repo count slowly decreases, the trend actually slowly seems to be increasing a little bit once it has fallen off the grace. Finally, there's the top 5 most used languages. Since it's the United States, and no country no year had been selected, we have actually made this chart more interactable with the year. Similarly, here's the word cloud. Word cloud also changes with the United States. Okay, now let us take an example of United States on the year 2008. So you can see now the number has changed, like the users count has changed from 1600 to 2064. And similarly the years, and there's the United States, and similarly the GitHub users is 25%. Moving on, you can see there's the same thing in the bar chart. The hireable are 336, sorry, and the non-hireables are 1343. That means there's no change. Similarly, now you can see the language, there's no difference actually, and the major difference we can see here is of the top 5 most used languages. Earlier it was JavaScript, which is still on the here line chart here, but once I click the Ruby, you can see the Ruby has been going down from like 100% to almost 0%. And similarly, on the year 2008 on United States, there were 5 most used languages, and those languages were Ruby, JavaScript, Python, Java, and PHP. So and from on the right side of the chart, we can see the Ruby has been slowly going down the hill. So let us take an example of year 2008, 2009, sorry. On taking the 2009, you can see the JavaScript is now the major language, and Ruby is just the second one. And this explains the chart as well, like the Ruby was at the top and now it's degrading. Now similarly, on 2012, you can see JavaScript is there, Python is there, Java is there, C++ and Go is there, but there's no Ruby. So once I click the JavaScript, you can see there's the growth of JavaScript as a language. Like in the 2007, we have seen earlier, there were very few JavaScript. Not that JavaScript was less, but there was definitely an increase in the number of users using the language JavaScript. And similarly, there's the word cloud. So this is how we have prepared our GitHub dashboard, and you can see. Okay, let me clear all of this. Now you can see the choropleth map actually changes with number of years. Like on the year, this was the total users count, and similarly on the year, this was the total users count, and similarly on 2012, the choropleth map has been changing, and the different shades of blue means there's a change of users, and the gray one means there are no users. Thank you.